Let me just wait for a second and look down here. Yes, I am online. Yes, it is working. Just figuring things out on this Twitch space. And let me just share the link to this on the internet. So just a second. Solidity. There it goes. Tweet. Tweet indeed. Okay, cool. Just a second. LinkedIn has become like the Facebook of professionals. Okay, cool. What the heck? Where is it? Just a second. I know I am taking a lot of time to start this, but wait a second. Wait. Okay, cool. Okay, fine, great. Yes. Okay, so chapter 1, lesson 2 overview. In the first stream yesterday, I completed the first chapter, and this is the first chapter is lesson 1, I guess. Then it's the chapter 1 but lesson 2 or something. Yeah. So okay, so in lesson 1 we created a function. Yeah, we did zombie feeding. When a zombie feeds, it infects the host with a virus. The virus then turns the host into a new zombie that joins your army. The new zombie's DNA will be calculated from the previous zombie's DNA and the host's DNA. Okay, fine. Okay, cool. And what do our zombies like to feed on most? To find out, you will have to complete lesson 2. Indeed. Put it to test. There's a simple demo of feeding to the right place. Click on the human to see what happens when your zombie feeds. Clicked. Okay, this happened. So basically the human's DNA and the zombie's DNA make up a new mutant zombie, like currently happening in the world with COVID. New variants are being made. That is what it is. So next, let's make our game multiplayer by giving the zombies in our database an owner. To do this, we will the zombie is in our database and we'll give it an owner. To this, we'll need new data types, mapping and address. The Ethereum blockchain is made up of accounts which you think of like bank accounts. An account has a balance of Ether, the currency on the Ethereum blockchain. You can send and receive Ether payments to other accounts, just like your bank account can wire transfer money to other banks. Each account has an address which you can think of like a bank account. It's a unique identifier that points to that account, and it looks like this. Yes, the wallet address, right? This address belongs to Crypto Zombies team. If you are enjoying Crypto Zombies, you can send us some Ether, but yes, I did not have any Ether. Yeah, we will get into nitty-gritty of addresses in later lesson, but for now you only need to understand that an address is owned by a specific user or a smart contract. A specific user or a smart contract. So a user is a smart contract. Is it what you want to say? So we can use it as a unique ID for ownership of our zombies, right? When a user creates new zombies by interacting with our app, we will set an ownership of the zombies to the Ethereum address that called the function. To the Ethereum address that called the function, right? Okay, the Ethereum address which calls that function to make that new zombie that will be added to that Ethereum wallet or address. Okay, cool. So we map. In lesson 1 we looked at structs, arrays. Mapping are another way of storing organized data in Solidity. Defining a mapping looks like this. So for a financial app, storing a event that holds the user's account, address, event, public, account balance. Okay, so this is the variable, and it will store a event variable, or could be used to store slash lookup username based on user ID. Okay, user ID to username to name. A mapping is essentially a key value store for storing a mapping is essentially a key value store for storing and looking up data in the first place. The key is the address and the value is the event. Okay, right. Okay, got it. And in the second example, the key is a event and the value is a string, right? Okay, I'll put it to the test. To store zombie, create a mapping called zombie to owner. Okay, so mapping, and it will store what? The key will be event. Okay, so keys data type is event, and it stores what is, we will store and look up the zombies based on its ID and value of an address. Let's make this a public address. An address will be what? String, or okay, so it will store an address. Address is kind of a data type, and it will be a public address called zombie to owner. Nice. Create a mapping called owner zombie count where the key is an address. So mapping, this is a map, so now key is address and event, key is address, event, and create a mapping public owner zombie count. Okay, there's some problem. Public fine, great. So just not public, right? Okay, so this is how the mapping looks. Let's go to the next one. Message. And now that we have our mappings to keep track of who owns the, just a sec, just yes. Okay, so message sender. Now that we have our mappings to keep track of who owns a zombie, we will want to update the create zombie method to use them. Okay, so now that we have mappings to keep track of who owns the zombie, we will want to update the create zombie method to use them, right? So when someone calls the create zombie, he will, I don't know, okay, this guy is calling me. See, in Solidity there are a certain level of global variables that are available to functions. One of this is message.sender, which refers to the address of the person who called the current function, right? Okay, so in Solidity, a function execution always needs to start with an external caller. A contract will just sit on the blockchain doing nothing until someone calls one of its functions. Right. Okay, so there will always be a message or sender. yes, makes sense. Here's an example of message sender and updating a mapping. So this is a mapping we have made. A key is address, and then stores a int, uint, unsigned integer, and then there's a function which takes a number and update favorite number, and like we update this is the message sender is an address, it's a mapping, it stores a value. So it's probably calling somewhere here, set my number, public view. Okay, to publish public, and it just views things, does not change anything. This function returns a uint, retrieve the value stored in the sender's address. Will be 0 if sender hasn't called set my number yet. Return favorite number, the mapping, right? So first you have to set this, right? In this trivial example, anyone could call set my number and store uint in our contract. Yeah, anyone could call it, set this, map it, and then we call right using message sender gives you the security of Ethereum blockchain. The only way someone can modify someone else's data would be to steal the private key associated with their Ethereum address, right? Okay, so put it to test. Let's update our create zombie method. Okay, so this is our create zombie method, right? Cool. We're passing a name and the DNA of the zombie. We are making it emitting an event, but between that what we have to do is, first after we get back the zombie's ID, new ID is made. Okay, so let's update our zombie to owner mapping to store message to sender under that ID. Okay, so where are the mappings? This one, right? So zombie to owner will basically contain under the ID, under this. Okay, what is this? Okay, caps lock is on. ID, the address. So the DNA, I guess. Sorry. Okay, so the user who calls this function will have a message of sender, so he will store that. So message dot sender, right? Yes. That's that. Second, let's increase owner zombie count for this message dot sender. Okay, owner zombie count. So it's a map, and it has, so it will map the ID plus 1. Let's increase the owner zombie count for this message dot sender. Okay, so what is the owner zombie count? Okay, sorry. So this mapping is actually containing a ID, right? ID, and when the person calls it, it stores under that ID, it stores the message dot sender, and then there's a owner's zombie count, which under the message dot sender, the address of the user calling it, it will increase the count of the zombies. Yeah, I mean, this should do it, right? Right, so the owner zombie count has the already whatever it has, and it will just increase it by 1. Okay, cool, nice. Its syntax is a bit weird. like okay, so chapter 4 require. In lesson 1 we made it so users can create new zombies by calling create random zombie and entering a name. However, if users could keep calling this function to create unlimited zombies in the army, the game would not be very fun. Let's make it so each player can only call this function once. That way new players will call it when they first start the game in order to create the initial zombie in their army. So how can we make it happen? So this function can be only called once per player. Require, for that we use require makes it so that the function will throw an error and stop executing if some condition is not true. Okay, right, make returns everything's normal. This generates a random string. Okay, so it requires this guy. Compare if name equals Vitalik. So if the name passed is Vitalik, according after encrypting it with using this K256 thing, if that works, it will return true, also it will throw an error. For this function it will return high. If you call it with any other input, it will throw an error and not execute, right? So let's use require to make this function only get executed one time per user when they create the first zombie. Put a require statement at the beginning of the create zombie. So okay, so what we have to do is just require. When someone comes to require a zombie, what we're going to check is that owner zombie count, address of the sender, message dot sender. If this thing is equal to 0, then only it will go further, else it will just throw an error. I guess that's what it is about. Yes, indeed. Right, so mess require is checks stuff, then only it allows stuff, right? Alright, cool. Next. Okay, so inheritance, very familiar word. Inheritance, Java. Our game code is getting quite long. Rather than making one extremely long contract, like sometimes it makes sense to split your code logically across multiple contracts to organize the code. One feature of Solidity that makes this more manageable is contract inheritance. Okay, so this is one contract, Doge, which has a function returns this memory string to the memory. Then there is a baby Doge. Okay, contract baby Doge is Doge function. This also returns this guy. Okay, cool. It's like, okay, inheritance basically. Like I remember, like it can be a shape and this is a triangle. The examples of inheritance when I read it. So baby Doge inherits from Doge. That means that when you compile and deploy baby Doge, it will also have access to this guy, right? It will have access to both these functions because it is inherited. Obviously, like baby Doge will have the properties of Doge, right? And any other public function we may define in Doge. Okay, cool. So to put it to test, we will make a contract somewhere here. How do we make a contract? We write contract zombie factory and boom. Okay, you'll notice that we just cleaned up the code to the right, and you now have tabs at the top of your editor, right? I see zombie fitting, and it has it has access to this guy, all its variables, functions, whatever. When you import this is how you import. Okay, so I have to import, so it's just like JavaScript. Import /zombie factory .sol. Okay, chapter 7, storage versus memory, data location. In Solidity, there are two locations you can store variables: in storage and in memory. Storage refers to variables stored permanently on the blockchain. Memory variables are temporary and are erased between external function calls to your contract. Okay, got it. Think of it like a computer hard disk versus RAM. So when you're using that, it knows, the memory knows what it has, but in storage it just remains in this blockchain. Most of the time you don't need to use this keyword because Solidity handles them by default. State variables declared outside of the functions are by default storage, right? They remain in the blockchain, but inside function they must be in memory. Yes, makes sense. However, there are times when you need to use these keywords, namely when dealing with structs and arrays within the functions. Okay, how? We have this struct, it has a name, status, sandwich on the array of the struct, and then function, which is public, takes argument as index, then give you a warning telling that you should explicitly declare storage or memory here. So instead you should just declare storage keyword like sandwich storage, my sandwich. Okay, so with this line it will give me an error, but you have to declare storage, in which case my sandwich is a pointer. Sorry, where is my sandwich? Okay, this is a pointer to the sandwich index in storage, right? And my sandwich dot status will be eaten. This will permanently change sandwich index on the blockchain, right? So you make this object from the struct, and then what do? You add that index. Okay, you add this index, and what is this index? Okay, it's coming from here. So basically access one sandwich from the array, you store it to in the blockchain as this struct. Okay, right. So in the blockchain there will be one sandwich. If you just want a copy, you can use memory, in which case another sandwich will simply be a copy of the data in memory, and another sandwich status will just modify the temporary variable and have no effect on index +1. But you can do this. Sandwich index +1 is equal to another sandwich, which is +1 is equal to another sandwich, if you want to copy the changes back to blockchain storage. Acha. Okay. Because this array is in the blockchain, because it's a state variable, it's out of the function, it's in the contract. So this is in the storage of blockchain, and we're accessing the blockchain, guys, and the thing in the blockchain, and in this execution, what is happening is that we are accessing the index plus 1. Let's say index is 0, we are accessing one index, the first or the second from 0 index. It's confusing. We'll take from 0, so 0 to 1, we are accessing the 1 sandwich, putting it in the memory, modifying that sandwich properties basically, and then we are again like replacing that in the blockchain. So this will be permanent. Don't worry if you don't understand when to use which one yet. The tutorial will tell you when to use storage and when to use. Fine. Okay. When a zombie feeds, it's time to give our zombies the ability to feed and multiply. When a zombie feeds on some other life form, its DNA combines with other life form to create a new zombie, right? The mutant guy. Create a function called feed. Function feed and multiply. It will take two parameters, a uint, that is zombie ID, and also a uint, that is this is a human's target, and that is a zombie's ID, right? This function should be public. We don't want to let someone else feed our zombie, so first let's make sure we own this zombie. Add a require statement to verify that the message sender, so the message sender who called this function to come first, and will mark wait a second. Add a require statement to verify the message sender is equal to this zombie's owner. So message sender is equal to zombie's owner. So how do we know the zombie's owner? So if I go here, so this is a zombie ID, and yes, this is it. So zombie ID. Cool. So if I just use the zombie to owner mapping, right? So zombie to owner mapping, and I put in the zombie's ID, it will give me the owner, and the one calling it should be similar guy. So that's that, I guess. If this happens, we'll proceed further, and which we are going to need to get the zombie's DNA. So the next thing our function should do is declare a local zombie named so zombie must be a struct here, zombie which has a name and DNA, local zombie. So next thing a function should do is declare zombie named my zombie, which will be a storage pointer. So this zombie will be stored in the blockchain, and set this variable to be equal to the index in a zombies array. So there is a zombies array we had made which has a lot of zombies. So in the zombies array, it will be of index what? Zombie ID, I guess. Yeah, right. So what we are doing is feed and multiply. So when a user calls this function, we will first check that is the calling user is the owner of the zombie, and if it is, then we will just store that zombie in the blockchain, right? Victory. Let's finish writing the feed and multiply function. The formula for calculating a new zombie's DNA is simple. The average between the zombie's DNA and the target's DNA by 2. later on we can find a formula for more complicated stuff, like adding some randomness to the new zombie's DNA, but for now we will keep it simple. We can always come back to it later, right? First we need to make sure that the target DNA isn't longer than 16 digits. Mod DNA modulus 16. So the target DNA that the user has sent us, right? So we can just do target DNA mod 16. This will bring back to less to the 16 digits. And next, our function should declare a event named new DNA, which will contain the zombies. So event new DNA, this will contain the average of both the target DNA plus the where is the zombie DNA? So I guess my zombie has it. This guy, my zombie dot, it has a DNA property which we just stored, and then we just do by 2. Yeah, once you have the new DNA, let's call create zombie to you can look at the zombie file. If you forget which parameters, note that it requires a name, so let's set a new zombie's name. So yeah, okay, we just made a new DNA. Now we are going to make the new zombie by calling the create zombie function, which takes a name and a DNA. So create zombie will take a name, which will be no name, and a DNA, which is, by the way, DNA. Cool, that's it. What is the problem? You may notice a problem with our code here. Okay, so you want me to do DNA modulus because it's a variable. We don't need to again call it. So you can see DNA 16 here, so we'll just use that. Yeah, that's that. And then what's wrong? You don't want to check, try again. Yes, that is gone. I think it's just somehow it just gives me error when it sees spaces. I don't know why. Is there something wrong here? What's wrong here? Showing the my zombie as a index of zombie. It has access to DNA, which I'm accessing here. You and new DNA. What's wrong here? Here it is. It says .dna. I've used that. It must be something silly. What? Hint. Is the hint not working? Okay, so this red lines. What about these red lines? What are these? those red lines are on. See, I don't know why the spaces also give error here. And it might seem very dumb debugging this like this, like changing the order, but it somehow it gives error due to the spaces. So I don't know what's happening. Somehow, see, we change the order, it fixes it, like wants what it wants. Okay, next. Okay, that was bad sound. More on function visibility. To the code in your previous example has a mistake. If you try compiling it, the compiler will throw an error. The issue is we tried calling create zombie from within a zombie feeding, but create zombie is a private function. Yeah, right. Did not notice that. Inside zombie factory, this means none of the contracts that inherit from the zombie factory can access it. Okay, got it. Internal, external, in addition to public and private. Solidity has two more types of visibility functions: internal and external. Internal is the same as private, except that it also accessible to contracts that inherit from this contract. Right, makes sense. Hey, that sounds like what we want here. Yes, we do. So what we're going to do is that we are going to just change it to inherit. External is similar to public, except that these functions can only be called outside the contract. They can't be called by other functions inside the contract. We'll talk about why you might want to use external versus public later. Okay, just a second. Somehow there has to be a lag in the stream for some reason. Let me just refresh it. Somehow it's just loading. It's just stuck on that loading screen. Just a second. Yep, it's working fine now. Yes. Cool. Okay, back to it. For declaring internal and external functions, syntax is the same as private and public. To test. Okay, private zombies for private to internal. Okay, sorry, it's internal, not inherit. God. Yeah. So inherit means when you use inherit, what that means is that only like if you use private, you should get an error if you try to call that function within your contract from a inheriting class. But if you use inherit, that will work. And if you use external, any inside function can't call that function. Only outer people can call it. What do zombies eat? It's time to feed our zombies. And what do zombies eat the most? Humans. No, okay, not humans. That was dark. Well, it just so happens crypto zombies love to eat crypto kitties. Ooh. Yes, I'm serious. Okay. In order to do this, we will need to read the kitty DNA from the CryptoKitties smart contract. We can do that because CryptoKitties data is stored openly on the blockchain. Isn't blockchain cool? Yeah, it is. It is. Okay, so where is that? Interacting with other contracts. For our contract to talk to another contract on the blockchain that we don't own, first we need to define an interface. I think we are getting into the real stuff. We are now talking to other blockchains. Let's look at the simple example. Say there was contract on the blockchain that looked like this. Okay, so this is a contract, and it has a mapping address int, number, and function is a function set num, and you sets the calling guy address to a event, and get number just gives that event. Right, this would be simple contract. This would be a simple contract where anyone could store these lucky numbers and it will be associated with their Ethereum address. Right, makes sense. When you call it, you store that number what you want. Now let's say we had an external contract that wanted to read the data in this contract using get num. Right, first we have to define an interface of the lucky number contract. Okay, so interface, right? Okay, it's just like literally like interface. We use interface to talk to someone, right? So a contract should have its own interface so that any other contract could talk to it and get to know things. First I have to define an interface. So this looks like defining a contract with number interface. For once we are only declaring the functions we want to interact with, in this case get num, and we don't mention any other function or state variable. Secondly, we are not defining the function bodies. Instead of curly braces, we are just simply ending the function with a semicolon. So okay, yeah, it's like an interface. Yes, got it. Yeah, it's like in Java, C++, we just write the function here. By including this interface in our dApps code, our contract knows what other contract functions look like, how to call them, and what sort of response to expect. We will get into actually calling other contracts function in the next lesson, but for now let's declare our interface for CryptoKitties. Okay, so is there a CryptoKitty really, or what? Crypto oh really, holy, what is this? Collect and breed forever. Ooh, play on the words indeed, why not? What is CryptoKitties? CryptoKitties is a game centered around breedable, collectible, and oh so adorable creatures we call CryptoKitties. Why are not there crypto dogs? Just kitties. Why kitties? I guess because they are famous in the internet. That's why. Each cat is one of a kind and 100% owned by you. It cannot be replicated, taken away, or destroyed. Right. There are a lot of users though. It's like the zombie. It has 12 like attributes. Our zombie had some attributes, and you can change those. Right now, it's kind of making sense, you know, like yes. It's like 0.14 ETH. mother is virgin. Oh, she has a mother and a father. Wow, they have really planned it out. Your MetaMask law simply open instructions to lock it. No, I'll not do that. But yeah, this is fascinating. Alright, okay. We have looked at the cryptocurrency source code for you and found a function called getKitty. They have this interface called getKitty and a function that returns all the kitty's data, including its genes, which is what our zombie game needs to form a new zombie. Okay, so this is the kitty's function that we can call and interact with. This returns all these things. If this variable is 0, then it's not gestating. Where is the ID? Okay, we need to pass in a ID. Okay. So when I call this function, I will be passing an ID, and obviously I will be passing myself as a message or sender, right? This function looks a bit different from what we're used to. You can see it returns a bunch of things. If you are coming from programming language like JavaScript, this is different. In Solidity, you can return more than one value from a function. Well, yes. I mean, you can also yes, in JavaScript you can return many values, but if you just make it an object, you can do that. But yeah, it's single object, but you can like return lots of things individually here. That is new. Define an interface called kitty interface. Alright, okay, so how do you do that? Remember, this looks just like creating a new contract. Okay, contract and kitty interface. Remember, this looks like a contract. Inside the interface, define the function getKitty, which should be able to copy and paste the function ever, but with the semicolon after the return statements. Instead of everything, return the curly braces. Okay, so this code is in their chain, like this is a contract this is a function in the CryptoKitties contract. They do all this stuff and return this, but as I just want to use it, my program needs to know what are the things it's going to return. It will actually just know this. Right, makes sense. Okay, now we will use this interface to get things, right, to call. Continuing with our previous example with number interface, once we have defined the interface as this, you can use it in a contract as follows. Number interface will have number contract, number interface address. This address of the favorite number contract. Okay, Ethereum number interface contract. What is happening here? Number interface is a variable of the interface and type, and then wrapping number interface address is providing the address to the interface. Right now, number contract is pointing to other contract. Okay. We call the get num from this contract, number contract. So the number contract is pointing to the other contract after I give it the address, and then it calls this function sending the message dot sender as the address, right, and do something with num here. In this way, your contract can interact with any other contract on the Ethereum blockchain as long as they expose those functions as public or external. Right. I have saved the address of cryptocurrency smart contract. I have saved the address of cryptocurrency. Okay, so this is the address of the CryptoKitty thing, right, which is unique everywhere, and initialize the kitty contract using secret address, right? So we were going to use our interface that we have declared, which has the function of what it will return. It's like the TypeScript interface that we know that, hey, this is the thing it is going to return, right? So we can handle things. So kitty interface has a kitty contract which will be done by ck address, just this, and what we're going to do is wrap this kitty contract with this thing, and it here. Now we have access to that contract we have connected, and we are going to use that function, right? Create a kitty interface named initialize the ck address. Yes, right. So we need this address to connect to any other contract, right? And we also need the this function, right? Handling multiple return values. This getKitty function is the first example we have seen that returns multiple values. Let's look at how to handle them. So function multiple returns, internal means inheriting, anyone can, in private guy can call it, returns event abc. Okay, so it's kind of like destructures stuff. Function process multiple returns external. So you are calling it, and it's like JavaScript. Okay. Make a function called feed on kitty. Where make a function called feed on kitty, and it will take two parameters. So you int zombie id, you int stick zombie id, and kitty id. And what it will do is function should first declare a event named kitty DNA. Kitty interface genes is a UN256, but if you remember back, yes, typecasting. Okay, right. The function should then call kitty contract dot get kitty to with the message sender, I guess, or not, with kitty id. And okay, so it takes the id of the kitty, which I will get from here, right? So it will call this. So we had declared here the kitty interface, we have connected, this is what I have access to, the contract, and this contract is going to call the function which was get kitty. So get kitty with the kitty id and what, and store the genes in the kitty DNA. Genes, right? So like 1 2 3 4 5 6 7 8 9. So I guess 1 2 3 4 5 6 7 8 9, and we have the kitty DNA. I guess that's how it's done. Feed and multiply and pass it both these guys. Okay, feed and multiply and pass it both the zombie id and the kitty DNA. So zombie id and the kitty DNA, feed and multiply. Finally the function should call feed and multiply, pass in the zombie id and what are those? From where will I pass? Do I need to pass? No, I don't think so. Let's see the errors. Okay, so there's some errors here. What's wrong with this? Function feed on kitty takes a event and public is public. Okay, that's solved. See, the spaces are giving me errors, the spaces. And now what it runs 1 2 3 4 5 6 7 8 9. 10th one is gene. 3 4 5 6 7 8 9. 10th one is kitty DNA. That's solved. last one. Yes, there should not be there. There's no error. Still there's a problem because we are not calling this guy feed and multiply, but I just can't understand where do I like now from where do I bring the zombie ID and the target DNA. Feed and multiply function, there's just functions. Do I give just anything here? Maybe this is definitely wrong. I'm doing something really silly. Okay, kitty DNA. Do we have access to kitty DNA somewhere? I think we have. Show me the answer. Oh, what the hell? Shit. Yes, what am I doing? Just forget why we are doing this. We are going to feed on the kitty. So, yes, what am I doing? What the heck? Okay, right. Call it here. What am I thinking? Kitty DNA and the zombie ID. So what happens is that actually this guy feeds on the kitty zombies, checks whether zombie is of the owner or not, and zombie storage gets the zombie of that ID, gets his DNA, makes a new DNA, creates a new zombie. Makes sense. Three more chapters. Bonus kitty genes. Our functional logic is now complete, but now let's add in one more bonus feature. Let's make it so zombies made from kitties have some unique feature that show they are cat zombies. To do this, we can add some special kitty code in zombies DNA. If you recall from lesson 1, we are currently only using first 12 digits or the first 16 digit DNA to determine the zombie's appearance. So let's use the last 2 unused digit to handle the special characters. We'll say that the cat zombies have 99 as their last digits of the DNA, since cat have 9 lives. Okay, so in our code we will say if a zombie comes out from a cat, let's set the digits of the DNA to 99. Well, how do you do that? After we have create zombies, the new zombies, we just have to modify this guy's last 2 digits to do that. See, add in statement here, which will not here, the new DNA is right, new DNA's last 2 digits. So how do you do that in Solidity? If statements in Solidity, if statements, right, just like you require. First change the feed and multiply so that it takes a string species, takes that, and let's set an if statement comparing which will store in the memory string okay. So memory was, it takes by value. Normally it takes a value. When you use memory, it takes a value, right? Yes. Um, okay. Mod 100 gives me the last 2 digits. I make it. Yeah, that is a good way to do it. Good way. So new DNA would be just take the new DNA plus, actually minus, then you actually new DNA, what it is, new DNA mod 100 gives you the last 2 digits. When you minus it, you are left with last 2 digits as 00. Then you add 99, become 99. You have the cat DNA. Lastly, we need to change the function call inside the feed on kitty, where we add the kitty to it. Okay, so just add here kitty, right? Definitely there is that. Where is this line? Yeah, it's all gone. Yeah, why is it not working? The if statement, we haven't used that. Let's add in. Okay, I'll pick up that letter Just it's going to finish. So what are we going to do? If let's add an if statement comparing the k256 hashes of species and string kitty. Okay, nice. If we can't directly pass strings to k256, instead we will pass right, makes sense. That makes sense. So this is normal code. This is what will happen if we don't have a kitty thing going on, but if we have it, so key sac 256, let's pick up that later. ABI dot encode packed boom, zombie. Next chapter, I think it's just a revision kind of thing now. Wrapping it up. JavaScript implementation. Once you are deployed to the we're ready to deploy this contract to Ethereum, we will just compile and deploy zombie feeding. Since this contract is our final contract that inherits from the zombie factory and has access to all the public methods in both the contracts. Okay, yes, that's right. Let's look at the implementation of interacting with our deployed contract using JavaScript and web3.js. So we have this API. So web3.js has the API thing. Our contract address Ethereum after deploying the contract. So after deploying this contract, we'll have an address like we had for the kitty thing. Then we add zombie feeding our contract API and an address. This is the contract. Assuming we have a zombie ID and kitty's ID, we want let zombie ID is equal to 1, kitty's ID is equal to 1. To get the CryptoKitties image, we need to query their web API. This mission isn't stored on the blockchain, just their web server. If everything was stored on the blockchain, we would not have to worry about the server going down, them changing their API, or company loading their assets if they don't like a zombies game. Let API URL be this, and then we just get those function data, image data.url, and actually clicks on the kitty.click. Is this dollar thing? Okay, something. Listen, when the user clicks on the kitty, feed on the kitty and listen for a new zombie event from our contract, so you can display it. New zombie is a contract, right? It's a event, so when it emits, and then this function will display zombie like in lesson 1, gendered zombie, result name, result DNA, right? So if we just do this, this is the 99 thing we added. This is now converted to this guy, right? So that's done. Lesson 2 of Crypto Zombies. On Twitter. What's the next lesson? Advanced Solidity concepts, right? I'll just see what we can do with all these things we have learned, and then I'll see, okay, what with the advanced stuff. So yeah, that's it for the stream, and I'll just stop the stream. Bye to me, as I'm the one guy watching me, so that's really cool. and stop streaming. Bye bye everyone. Really, it's me.